Hello and welcome to the December edition of our ACPA webinar series. Today's topic is ETCulvert design and rating of precast culverts using LRFD. Our presenter for this topic is Brian Barngrover, who is Vice President of Ericsson Technologies. He has worked for precast concrete fabricators and has over 30 years experience in software development. Also, along with Brian is his associate Frank Holz, who will be online and answering questions that y'all may have. Just go ahead and type them into the question box or the chat. So we're going to go ahead and get started, Brian.
All right, thank you, Corey. Good afternoon. This is Brian Barngrover with Ericsson Technologies. And as Corey said, today's topic is the design and rating of precast culverts under LRFD using ETCulvert. So let's get to it. First topic today is the overview of the design process using ETCulvert. Starting a new problem is fairly straightforward. We have a number of built-in problems for you to select. You can start with either rebar or mesh. I find, though, it's easy just to start with a single cell precast with 4 sides because it's so easy to change the other parameters that just starting with that, I can start with a 3-sided and end up with a 4-sided triple cell if I wanted to. So it doesn't matter what you start with. Very easy to change. Another option for starting a new problem is initialize it using the seed file. Here you just select any file on any ETCulvert file on your hard drive. Won't destroy the original file. It just populates a whole brand new problem with the seed file. You can create a library of problem types. Or, for example, if you have practices or you ship to multiple states, you can set up a seed file for each state. One thing we find a lot is that covers, the rebar covers, tend to change a lot between states. So that's one use for a seed file. Set up multiple states. You can also open an existing problem. ETCulvert has a standard Windows Open File dialog box to go, or you can also, through Windows Explorer, just double-click on an ETCulvert data file. That will also start the program. You're going to hear me talk a lot today about operating modes. ETCulvert has 2 modes of operation. We call them design mode and analysis mode. Design mode is fully automatic. It will size the members for you. It will size all the reinforcement and the spacing. In analysis mode then, when you go to analysis mode, you can change any or all of the dimensions or any or all of the rebar and their spacing. In design mode, the program will automatically size the members for you, or you can fix the size of the members, as I'll show you later in the presentation. And it will then, additionally, it'll automatically select and size the reinforcement and spacing for that reinforcement. In analysis mode, you assign all the member sizes yourself if you wish, and you can change any of the reinforcement size or spacing. Throughout the design process, you can look at 2D sketches in what we call our main view, and then also right adjacent to the main view, we have a comprehensive text report that will show you the current status of the design. We call this a parametric process, and what we mean by that is every time you press an OK button from any dialog box, all of the output is automatically updated. You don't have to do anything special to run an analysis. As soon as you exit that dialog box, all of the views, the main view, all of our 2D sketches, the text report, everything is completely updated for you. We also have a comprehensive moving load analysis. And what we mean by comprehensive is you can input any number of axles. You can have variable spacing. The axles can be any weight. They can be all different weights. If you have a multi-cell culvert, we do what's called a pattern lane load to capture the correct moment and shear diagram. You can use any combination of truck and lane load. We also have a dedicated tandem load available, although you can also model a tandem load just using a regular truck. Reinforcement types supported. We have all the U.S. customary standard bar sizes to select. We also include a number of mesh sizes, both smooth and deformed. Another area of topic that you'll hear me talk a lot about today is our critical section table. Here's the meat of the text report is right here in the critical section table. We have detailed tables in the text report for both flexural and shear critical sections. You can include the effect of haunches in determining location of the critical section. So as you'll see later in the presentation, you'll have a number of choices of where you can set that critical section for both shear and flexure. Also a nice feature we have is that critical section table includes ratings automatically. You don't have to do anything special. Every time you get a design, you'll get a rating. And we include both the operating and inventory ratings right in that critical section table. What I was talking about in terms of where you can place the critical section, you have 3 possible locations at the ends of the members for the critical section location for flexure. The most conservative is at the face of the intersecting member, as you see here. You can also place the critical section for flexure within the haunch, where 1.5 times the member depth intersects the haunch. And lastly, for flexure, at the end, you can select your critical section for flexure at the intersection of the haunch and slab. And of course, also, we'll get the midspan of the member as well as a critical section for flexure. That should be where your positive moment generally controls. For shear, you have 2 possible locations for the location of the critical section. The first and most conservative is at the D or D sub B from the face of the intersecting member. But you can also push it out so that it's D or D sub B from the toe of the haunch. A little less conservative, but still perfectly acceptable. And of course, we also include the midspan critical section for shear as well, although I doubt that ever controls, but it's there for you. And we got a question for you.
So the first quick poll is, what is your typical reinforcement in a culvert? Please select one of the answers below. Okay. At about 91%, 7% use rebar only, 67% mesh only, and 26% use a combination.
Okay.
Let me give you the screen back. Okay.
Thank you. Next topic is the typical progression of design when you sit down and open up the program. So the first thing you do is start a new problem. As I said, we've got multiple built-in problems, and that's usually where I start. That's easiest to me. You just start with a rebar mesh single-cell four-sided culvert and go from there. I usually find that the easiest. Then you select your code and your agency. Whatever the governing code is, we support, as you can see, LRFD, Standard, and REMA. Now, when you select the code, that will change some of the options that you'll see in later dialog boxes. When we design interfaces, and as a user, I see the same design that other people do, we try not to disable or enable input controls on one window that's controlled by something you did on another window. That gets really frustrating when you see that. So anytime you see in one of our input windows that something is disabled or missing, you can pretty much always assume that's because of whatever specification you selected here. There's a couple places that are different, and I'll point those out when we get to them. You can also select your agency here, and by agency we mean like New York State DOT, Texas DOT, something like that. And all that happens when you select a particular agency is that it'll set some of your input for you automatically. It won't turn on or off any of the controls, but it will set some of the controls for you automatically. If you don't see your particular local DOT here, let us know. We're always adding new agencies, so if you don't see one, tell us, and we'll add it for you. Not a big deal. Next up is selecting the program operation. We strongly suggest you start your new problem with design mode, not analysis mode. Start with design mode. The current mode and the selected specification will always be shown in the lower right-hand corner of your status bar. So check there if you don't remember what you did. Then proceed typically to inputting the dimensions of the culvert. You can have from anywhere from 1 to 4 cells. You input your clear span, your clear height, and the length of your culvert here. Also on that same page is you identify your fill depths to check. You can select one fill depth, or you can select a range of fill depths. Remember, there's a paradigm switch between less than 2 feet and greater than 2 feet. So a typical fill depth to check is 1.99 feet. So if your range includes 1.99 feet, we will add that fill depth for you automatically. Don't worry about trying to mess with your increment to include it. We'll include it for you automatically. That range of fill depths will then show up on the text report, and will show the controlling depth for both the slab thicknesses and also for in the bar schedule table. We'll make sure you know exactly which depth controlled the selection of that particular rebar location or mesh location. Going back to the physical dimension page, wall and slab dimensions. Some agencies may have minimum thicknesses for walls and slabs, and if you give us your agency, we'll program that in. If you set it to 0, we have an internal algorithm that takes into account the clear span and the clear height, and we'll set some minimums for you, although you can always override those if you want to. In that same dialog box, we have a material properties page. Most of the time, the only thing you'll probably mess around with here is the concrete strength. But there's a lot of other, as you can see, there's a lot of other data that you can access here as well. Now here's a good place for seed files, because one thing, as I said before, one thing we see a lot of difference of between the various states and various regions of the country is that covers seem to change quite a bit. Now, it's not a big deal to input them here, but it's a good place to use a seed file to set those covers for you automatically. One other thing here I wanted to point out on this particular page is what we call the reinforcing diameter. During the design process, we haven't selected the steel yet, so we don't know the diameter, and we can't calculate D. But so we use this parameter here in the calculation of D. This is 1 inch, which is the number 8 bar, kind of an average size. If you have mesh, you should probably think about reducing that. The next dialog box you should look at then is the loads dialog box. And right up at the top there is the live load. This is where you select or define your truck. Now those trucks are contained in individual files, so you can share those with others in your office. Ask us. We may have already created a truck for that particular vehicle. Ask us. We may have a truck file. Okay. It's very easy to define it though if you need to. Here's where you define it. You can change the axle spacing. You have any number of axles you want to. No limit on the number of axles. The magnitude is also completely under your control. You can also define lane and tandem loads over here on the right. Don't forget to also set the combination of truck loads and lane loads. The first one, truck plus lane or tandem plus lane, is for LRFD. The second one, truck or tandem or lane, is for standard or arena. Now, we put a checkbox here to let you turn the lane load off. You could have done it. You could have done it back here and set this to 0, but then you might forget it and might forget to include it. So we put it here. So this is a place to include or not include your lane load, because some boxes, some various structures require lane load and some don't. It depends. The dead loads, you can apply the distributed or concentrated dead load. Remember that we are analyzing a 1 foot wide structure, so apply the dead loads as per a 1 foot wide strip. The program uses the equivalent fluid pressure method for lateral soil loads. The soil weight itself, though, is used for vertical loads. However, for AREMA, here both the vertical and horizontal loads are based on the weight of the soil. The final page that we have that you may need during a typical run is the analysis options page. Now there's a lot of stuff here, and we'll go over some of this stuff later on in the presentation. But for the typical run, probably the only thing you need to worry about is the upper left-hand corner there, the member thickness. Now if you work for a precaster, chances are the thickness of the member has already been decided before it gets to you. But you can still use design mode though. So go into design mode, set your member thicknesses there, and then come back here and fix them all. So it won't change the member thickness during design mode, but it will go ahead and size and space the reinforcement for you. Now this is one place, as I said, there was a couple places where you're not going to get access to anything that is not dependent on the specification that you selected, and here's one of them. This panel will not be available during analysis mode. You can only fix or variable during design mode. So that's one place that you're not going to have access to. So after your initial run or runs in design mode, that's when you can switch to analysis mode to tweak the design. Shift the reinforcement around a little bit or whatever you think you need to have to do to get it to work. One thing to remember though is that you can only switch, if you need to switch reinforcement types between rebar or to mesh or mesh back to rebar, you've got to do that in design mode before you switch to analysis mode. And here's that other place I was talking about where the availability of the control is not dependent on the specification but on something else. And it's dependent on whether or not you're in design or analysis mode. Now the reason we require you to switch it during design mode is we have to build a reinforcement table so that you can have access to it to change what you want. And we can only build that reinforcement table in design mode. So that's one thing to remember. If you have to switch reinforcement types, you have to be in design mode first. One other thing to pay attention to is if you have a permit load, the way you signal to the program that you have a permit load is to go to the analysis options page and select use strength 2. That will let the program know that that wheel load or that vehicle is a permit vehicle. Then on the text report in the critical section table, remember that only the operating rating is applicable over here on the very right to permit loads. In fact, that's why we put strength 2 in the top. So don't worry about if you're not meeting the inventory rating for a permit load. You only have to meet the operating rating. Now we have another poll question.
So for our second poll question, what percentage of your time using ETCulvert is spent in design mode versus analysis mode? Only select one of the answers. We're at about 55% voted. Looks like about 62% have voted. Give it another 20 seconds.
Okay.
So 72% have voted. 30% said 50-50, 30% said 70% design mode, 30% analysis mode, 12% for 30% design mode, 70% analysis, and 18%, 60% design mode, 40% analysis mode. I'm going to hand it back to you.
All right. Okay, the next topic is common design questions. These are questions we get through our tech support where people are asking, how do I handle such and such? So these are the 4 most common ones you see on your screen now. And the first one is skewed culverts. How do you handle skewed culverts? We probably get that more than anything else. So the first case is, for a skewed culvert, is when only the exterior culvert is skewed. And this is primarily for LRFD users. So what do you do if only the exterior culvert is skewed? Well, it depends on the skew angle. So we'll do a little live demo here. And say, for example, your skew angle is only 10 degrees. Okay? Well, LRFD says you only have to worry about skew. You only have to take the skew into account if you're greater than 15 degrees. So if you're less than 15 degrees, 10 degrees, we don't feel there's anything you have to do. You input the clear span as being the leg of the triangle, and you keep the truck parallel to the main reinforcement, and you're set. That's really all. We believe that's all you have to do in LRFD. Now, the second one gets a little trickier then. When you have a skew angle of greater than 15 degrees, now LRFD says you must take that into account. So say we got a 20-degree skew, all right? Well, our recommendation is leave the clear span still as the leg of the triangle here, but now set your traffic direction to perpendicular to the main reinforcement, all right? We believe this should account for the skew angle. You can do that in 2 places. You can set your lanes perpendicular here in the loads dialog box. That's perfectly acceptable. Or you can also, if you go to your analysis options page, you can, under live load analysis, you can automatically set the traffic direction to account for skew effects. And that will do essentially the same thing. If you input a skew angle of greater than 15 degrees, it will turn the truck perpendicular for you. So either way will work. So that's the first case. All right. Second case is when all culverts are skewed. You probably see this more often. For this condition, what we recommend is setting the skew angle to 0, but now for the clear span, input the hypotenuse of the triangle that you see there. All right? So for example, we'll just assume that's 20 feet instead of 16. Okay? So input the longer clear span, and then go to loads, and input your lanes parallel to the main reinforcement. And make sure that under, if you've been messing around with this, make sure that back under analysis options, you've unchecked this automatically set skew angle. So that's our opinion on how to handle the skewed culverts for the second case when all culverts are skewed. The magnitude of skew is not important, but you do have to put in that longer dimension for the clear span. But that brings up another question, though, and this kind of segues into our next topic, is how are the number of lanes determined? Well, that depends on whether or not the traffic is parallel or perpendicular to the main reinforcement. So the first case is when the lanes are, or traffic is parallel to the main reinforcement. There we have some guidance from the LRFD specification. When we have less than 2 foot of fill depth, the LRFD specification says you only have to put on one lane of traffic with the appropriate multiple presence factor. When you have greater than 2 foot of fill depth, though, it says you probably ought to check several cases. So what we do is we check 5 cases. We go up to a maximum of 4 lanes, and the reason we get 5 cases out of 4 lanes is we check the 2-lane case twice. Here's how we check the 2-lane case. We set 2 trucks side by side in one check, and the second check we just check the 2 closest wheels to each other as the second check. So we end up with 5 cases, and we pick the maximum, the worst case of those 5 cases to use in the analysis. So that's how we determine the number of lanes for parallel to main reinforcement. Perpendicular, though, the code doesn't give us any guidance on how many lanes we should be placing on the culvert when the traffic's perpendicular. So here, we use 10-foot lanes and we round up. So, for example, if you have a 20-foot 6 clear span, we put on 3 lanes, because that's 2 10-foot lanes and 1 partial 10-foot lane, and we round up to get 3 10-foot lanes. And again, we place 1 foot, we place 1 lane, we place 2 lanes, we place 3 lanes with the appropriate multiple presence factor and figure out the worst case. Now, a caveat here is that may be a little overly conservative, because we're only using 10-foot lanes, not 12-foot lanes. So what we've done is, back on that loads dialog box, you can set the maximum number of lanes. You can specify only 1 or only 2 lanes if you think 3 is too many, and it may be. It depends. You have to use your judgment here. All right. Now, one other question we get in conjunction with this is, why are you only using the 10-foot lane? The code says you have a 10-foot loaded section of a 12-foot lane. Well, it also says you can place that 10-foot loaded section anywhere within that 12-foot lane, and that would make our moving load algorithm way too complex. So we go a little conservative, and we just use all 10-foot lanes, and it seems to work just fine. Another question we get a lot is going to, if you have a 3-sided frame, the default condition is, for supports, is pinned and pinned. But if your clear span to clear height ratio is greater than 4:1, you'll get a warning in your output, as you see here. The genesis of that warning is, in New York State DOT found years ago that when their 3-sided frames approached and exceeded a 4:1 span to depth ratio, they were getting greater deflections than what they calculated. So in order to account for that, they said, okay, in this condition, what we recommend is you also check it with a roller on, replace one of those pins with a roller. And so that's what we've done for you, okay? You can replace one of those pins with a roller. Now, it doesn't matter which pin you replace with the roller. It's a symmetrical shear and moment diagram. So we arbitrarily select the left node to place on a roller. And we'll get this support condition. This is your alternate support condition, that the span to depth ratio is greater than 4. Now, one thing you can do is you can open up multiple instances, or what we call instances, or runs of ETCulvert. So you can check this side by side. You can have the pin on one side and the pin roller condition on the other side. And what that does is what I always like to tell our junior engineers here is, sometimes you need to bound the problem. So that bounds your problem. The left side is the top member is acting as the top member of a frame, of a rigid frame. I'm sorry, the left side is, okay, sorry. The left side is acting as the top member of the rigid frame. And so you'll see a higher negative moment there, all right? The right side over here is the top member is acting more as a simple supported. So you'll see more positive moment still in that one, and that will give you a good bound of your problem right there. Another question we get a lot is, okay, what if I only have a single layer of reinforcement? And okay, we can do that in ETCulvert. And there's 5 areas that you need to look at when you're adjusting this to work with a single layer of reinforcement. The first one you have to worry about is getting your cover dimensions and your member size and your everything to work so that those 2 layers of reinforcement line up. So I've already set it up here. This is the 7-inch thick members. So if we use, you have to coordinate between the reinforcing covers and your reinforcing diameter to get all of the layers to line up. So that's really easy to do, and that's your first step, okay? Your second step then is to go into the text report and pick out those bars that you really need. Now, you have to remember that ETCulvert always assumes that your member is singly reinforced. So the only, for the main reinforcement or the reinforcement parallel to traffic flow, or the clear span actually, parallel to the clear span, the only reinforcement types, or bar marks we call them, that you need to worry about is your A1 and A2 bars, which is your negative moment reinforcement that you see here in the corners, your A100 and A200 bars, which are your positive moment reinforcement in the top and bottom slab, and your B2 bars, which is your main flexural reinforcement in the walls. You can safely ignore the B2, the A300, and the A400 bars. Not needed. Now, the next thing you have to worry about, the next step is getting your temperature and shrinkage steel correct for your walls. Or this is also known as the longitudinal steel. Now, these are called C1 bars in our bar schedule. You have a couple of options here. You can use all the C1 bars, which are the 2 bottom rows of your bar schedule. You can use all that you can use. You can put in 14 C1 bars if you want to in each wall. That will handle it. But remember, we use a floor or a minimum of about a number 4 at 12 inches on center. So if you look, the provided is 0.2 square inches, but all you really need is 0.84. So you could probably cut back on that and save yourself some steel. So whichever way you want to do it will work. Then the other thing you need to work on is your longitudinal steel in your top and bottom slabs. Now, in the top and bottom slabs, you may also have to account for distribution steel. That's fine. That's the C100 and the C200 bars. Those are distribution steel. So in the top and bottom slabs for your longitudinal reinforcement, you need to use the greater of your C100, your distribution steel, and your C1 bars, or in the top and bottom slabs. Again, though, be careful because we're using again a minimum for that C1 bar. So check your rebar table over here, your reinforcement table, and check the required. That may be less than number 4 is at 12 inches on center, so you might again be able to save some steel, but you can't go wrong by using the combination of the C100 and the C1 bars. That will definitely get you there. And the final check then, this is something you may have to do by hand, but I doubt if you'll ever need to worry about it. Your final check is to make sure that main reinforcement satisfies the temperature and shrinkage requirements in that direction. And time for another poll question.
All right, time for our final poll question. What other types of engineering software do you use in your office? And you can select all that apply for this. We're at 70%. We'll give it another 30 seconds or so.
Okay, no rush.
Okay, so about 73% voted. It looks like
Okay.
large portion use the general purpose matrix analysis and also the retaining wall design. And
good.
Bridges. Only 2% had the pre-stressed beam design for buildings.
Okay. We see that. Okay, that's
All
our
right.
last poll.
Take it away.
All right. The last section we'll talk about today are advanced topics. Now, if you remember on that analysis options page, we had a whole bunch of options to look at, and we'll look at most of them here today. There's the first one though is not on that analysis options page, and that's in the load and resistance factors input dialog box. Okay. Typically, we use what's called a P-M diagram when we are calculating the flexural capacity of the member. We draw one internally, as you see there on the right, but you have some control over that. You can adjust the factors here that are used in pinpointing these actual points on the curve. So you have some control over that, but chances are this one will work for you. Okay. Right above that, you see that phi for the moment. That phi for the moment is not used unless the axial load is ignored, and we'll talk about that later on. But remember that you can change this phi, and you'll see it's not changing. And you'll say, why is that not changing? Well, we'll answer that in a bit here. Back on the analysis options page now, we have an option called combined axial overlaps for fills greater than 2 feet. Now, the LRFD code states that when the axles overlap, they should be combined. Well, we believe that this may be unconservative for short spans. So, and we'll show you what we mean here in a second. Okay, when the live load distribution is not selected, this is what happens when the soil depth gets large. These axles start to overlap, and you get what we believe a concentration of loads here that might control, we think, in short spans. It may not matter for long spans, but we think it might make a difference in short spans, as opposed to what the LRFD spec says to do if the axle starts to overlap. The magnitude is localized is less. So that's our opinion. Like I said, it may not matter for long spans. Now, a lot of you out there have probably used BOXCAR in the past, so we've included 3 options to mimic the analysis of BOXCAR. And this is the first one. When the fill depth is less than 2 feet, the old standard code and ARIMA required you to treat the wheel load as a point load, and that's conservative. When you get up to close to 2 feet, that tends to be a little conservative. So if you select this to always distribute that wheel load, it'll always treat it as a distributed load. If you approach 2 feet, it'll treat it as a distributed load and not as a concentrated load. So that's the first analysis option that we provide to you that will mimic the BOXCAR analysis. The second thing that BOXCAR does is it uses the haunch in the actual structural frame of the member. So what that effect is that it will increase your negative moment and decrease your positive moment. So we can do the same thing here in ETCulvert. If you're back here on the analysis options page, if you select to use haunches in the structural modeling, that will mimic that effect or that analysis option of BOXCAR. The final way you can mimic BOXCAR is to use the pipe equation from LRFD to calculate your flexural resistance. And this also, we also include in ETCulvert, we also include a multiplier for this n sub u factor. So you can set that equal to 0 and turn off the effects of n sub u if you wish, which will make it a little more conservative. Now remember I said back on the load resistance factors page is you can ignore the axial thrust. And what that does is it will use just pure flexure for the flexural resistance. And it will not use that P-M diagram at all, and will use whatever phi factor that you've included back on that load and resistance factors page. Some states require this, we found, so we put that in for that. Now, in the calculation of the shear resistance, some of those resistance equations use an interaction between V and M to calculate V sub C. Now, you can use the moment that occurs at the critical section in combination with the shear that occurs at the shear critical section for that interaction equation between V and M. But that's really not what's going on at the shear critical section. It's really a different moment there. But it's more conservative to use the moment at the critical section than it is to use the moment coincident with the shear. So we default to use the maximum moment with the maximum shear in that interaction equation, which is conservative. But if you don't want that, you can tell it not to use that, and it will give you a higher V sub C. Here's where, as I stated earlier, you have several sections to select from for using the, for selecting where the flexural critical section is at the ends of the members and where the shear critical section is at the ends of the members. And that is contained on the analysis options page and under the critical sections box. You can tell it to use consider the haunches, and extend the critical sections to move that critical section for flexure and shear to wherever you want it. It allows up to 3 different locations, as we saw before, for the flexural critical section, and it gives you a choice between 2 locations for the shear critical section. Another option we have in the on the analysis options page is what we call always check iterative beta. Now, if you go into Chapter 5 in LRFD, there's about 5, I believe, different ways of calculating the capacity of the concrete in shear. The one that they call the general option you can use anytime you want. The other 4 are, I guess you call them simplified methods, if you wish, to calculate V sub C. But you can always use the general section, the general case for calculating the shear resistance. We call that iterative beta because that's what you're doing. You're iterating to find beta and theta. But the code calls it the general method. So sometimes that results in a higher value. So you can go in here and check to always check iterative beta, and it will do potentially 2 checks then. The iterative beta check and the simplified method if your particular color dimensions and parameters allows that, and it'll give you the higher of those 2 values. So that's something to think about if you're having a little trouble with shear, because shear generally drives the member thickness calculation. So if you're having a little trouble getting that to work, think about always checking iterative beta. It doesn't take any more time, not a big deal. And I believe that's it. Thank you for attending. Questions, I think, Corey?
Yeah, we've had some questions. We'll just read them off. Most have already been responded to.
Yeah, Frank, I've got somebody here working, our QC engineer, who you may have talked to, some of you users. He's been answering questions here.
Okay. I'll read off some of these and give Frank's response. One was on the ARIMA code listed on the ETCulvert screen and was wondering if ETCulvert can handle the train loading. Frank's response was yes, any loading can be entered into ETCulvert, including a Cooper E80 loading. Also, go ahead.
And we have that truck file if you need it, or you can create it yourself. And I think we ship it. In fact, I think we're going to ship it in this next release. I believe we're going to ship that truck file with it.
Cool. Another question was on the version that was being used. They were wondering because they have version 2.17, and the reply was that you were using ARIMA version 2.5.
The Culvert,
ETCulvert, yes.
Right. Yeah. I was demoing. This presentation was using ETCulvert version 2.5, and I believe that's going to be out by tomorrow. We'll be posting that on our website tomorrow.
Okay. Cool. Another was a quick way to see if your design has worked or not for a culvert. Seems like you'll have to sit through many output pages. It's usually like 25 pages. And so a quick way to check if it has worked is to verify that all the ratings are above 1.0 and that you meet the serviceability requirements. And this is all on one page.
It is? Yep, that's right.
However, that page is generated for each of the fill depths, so each of those, that single page must be checked for each of the fill depths.
Okay. Then we've had some more just pop up. Can ETCulvert be used for vertically oriented boxes as BOXCAR could?
Not at this time, no.
There are some ways you can fudge in the numbers, but it's not natively handling vertically oriented culverts.
That's a good question, though. We'll have to think about that one. But right now, I'd have to say no. But we will take a look at that.
Okay. Here's another one, which I guess is similar to the last one. It's, can we design three-sided box culverts upside down using the base slab on the ground with removable slab top?
Not in this version, but that's something that we're going to be adding next year.
Okay, cool. Does the software consider Canadian codes?
Again, not right now, but that's another thing we promised to add next year, which we will. We come out with about one major release a year, and those two things we just named off are both in our next major release, which will be next year.
Okay. Here's another. What does one floating seat network license cost?
I'm sorry, what was that again? I'm sorry?
What does one floating seat network license cost? You'd have to call and ask. I don't know off the top of my head. Okay.
But call and ask, and we'll be happy to give you that number.
Yeah, pricing information is also available on our website. There are other options available for enterprises and such, but if you give us a call, we'll be able to answer those questions. Our office manager, Kathy, will.
All right.
One thing I probably hasn't been mentioned, Brian, if I'm correct, ACPA members do get a discount on licensing.
Yes, thank you, Kim. Yes, you were correct. ACPA members will get a discount on licensing, yes. Mm-hmm.
And then also I think we might have a couple of DOTs on this call, and they can actually receive a free copy if they're just doing checks, correct?
Yes, DOTs get what we call a reference license, which is free. As long as they're using it just for checks, they can have it for free.
Okay. Will a hard copy manual be available for each ETCulvert disk?
We don't print out hard copy manuals anymore to save on paper, but every installation comes with both a manual and a QC document in PDF format.
Those are unlocked for printing, so they can print it on their own printer.
Correct.
If they'd like.
It's unlocked for printing, so you're welcome to print it on your own printer if you want. Good point.
Okay. Can shear be checked at the haunch slab interface? Example, fill less than 2 feet using point loads.
I'm not sure if I understand that one. I'm sorry. Read it again.
Can the shear be checked at the haunch slab interface. The example they used was fill less than 2 feet using point loads.
The first part of that question, that is one of the options for critical section checks for shear. And you can enter, have the loads be put in as point loads. So I think the answer to the question is yes, if we're understanding correctly.
Yeah, if we understand the question correctly, yes. But if that user wants to call us or send us a data file, we'll take a closer look at that to make sure we understand it.
Okay. And where can I purchase the software? When can I purchase it? I think y'all already answered that, but.
Yeah, well, you can go to our website, and I think there's even a link off the ACPA website too as well. So.
Yeah. And can the output be accessed by a Vertex program? I don't know if I'm saying that
Not
correctly.
yet. Again, that's something else we have on our to-do list for our next year's release. We will write Vertex files directly from ETCulvert.
And those can then be imported into Vertex.
Right. Mm-hmm.
Okay. Also, what edition of AASHTO LRFD?
It's good up to the 5th edition.
5th edition.
Yeah, because there's only one small change to the 6th edition that affected culvert design. Oh yeah, it's the 5th edition. The only thing that's different, I believe, is the cracking moment, but that shouldn't really affect your design too much.
Okay. Is there any option of external water pressure in addition to soil pressure?
External or internal?
External.
External.
No, other than the soil pressure, no. We have been asked about buoyancy effects, but we haven't had enough people ask us for that yet. So we haven't included that yet, but that's certainly something we can talk about. Again, if that person wants to call us directly and ask for it, we'll be happy to talk to them about that.
Okay. Does the fill height or the box include the top slab thickness? Florida DOT includes this top slab thickness. So I guess they're wondering if the fill height includes the top slab.
No, it doesn't, but you can certainly up the fill height yourself to include that, but we don't.
Okay. Is there tech assistance available for DOT approvals?
Yes, absolutely.
Okay. Let's see if there's any I've missed.
Yeah, one I saw that you missed, Corey, was whether or not the program works for vertical installations such as manholes.
No, you already asked that.
Okay.
We'd have to, he did catch that. We'd have to think about that. Off the top of my head, I'd say probably not, but we'd have to, let us take a look at that, all right? Let us think about that. See if there's a way we can do that.
Okay.
Another one I saw, Corey, was, maybe this was already answered also, when will ACPA be replacing BOXCAR with ETCulvert? ACPA is already currently no longer updating BOXCAR to current specs. So it will just be phased out because it will become obsolete.
All right. Thanks, Kim. Those questions started flying in.
It is.
All right. So we will be sending a PDH via email, and with that we'll have a couple of questions. And we'll be having a workshop at our pipe school. So these questions will help you better prepare for that workshop. And that will be on February 13th?
14th, Friday.
14th. Valentine's Day with the ETCulvert folks, so should be fun.
Sure, we'll be there.
All right. Well, thank you, Brian.
Thank you.
This will
Appreciate
conclude our session. Yep.